Certain animals in a rescue shelter must have at least 30 grams of protein and at least 20 grams of fat per feeding period. These nutrients come from food A, which costs 18 cents per unit and supplies 2 grams of protein and 4 grams of fat, and food B, which costs 12 cents per unit and has 6 grams of protein and 2 grams of fat. Food B is bought under a long-term contract requiring at least 2 units of B be used per serving. Another contract requires that the amount of food B used is no more than 3 times the amount of food A used. How much of each food must be bought to produce the minimum cost per serving? All right, there's a lot going on in this problem, right? You read that and your eyes kind of go crossed, but you just have to break it down. Start at the end. How much of each food, okay? How much of each food? So they're talking about what? Food A and food B? Okay, so let's say that X is food A and Y is food B. All right, that's what I would do, okay? And then notice we're trying to minimize cost. So if I'm setting up this problem, I know I'm going to be minimizing cost, okay? So I will say minimize C. And again, you can use Z, you can use the letter Z if you want every time, okay? But I like to use something that's descriptive for my problem. So minimize C for minimize cost. So the first thing that I would do is I would go through and try to find the numbers that are talking about cost. Okay, so where are we at here? See the word cost right here. Okay, so they're talking about food A right here costs 18 cents per unit for food A. And then they talk about B, which costs 12 cents per unit. Okay. So it looks like it's going to be 18x plus 12y. Because those are talking about costs. I'm minimizing cost. Find the numbers that are talking about cost. And don't use them again. Those numbers are used up. Okay. So you can cross them out if you want, but we're not using those numbers again. Now we talk about the constraints. So subject to, and we go look for inequalities. So when you see something like at least 30, okay, at least 30 tells me an inequality. At least, okay? Am I talking about numbers like 28 or numbers like 32? Which one of those is at least 30? 32, right? 32 is at least 30, okay? I'm talking about greater than or equal this time. You got to think really hard about what those words mean. At least 30 means something is going to be greater than or equal 30. So they're talking about protein, okay? At least 30 grams of protein, right? So find the other numbers that are talking about protein, okay? So when they're talking about food A, they say something about 2 grams of protein. So that's going to be 2x right there. And then when they're talking about food B, they say something about 6 grams of protein. So plus 6y. It's all about put them in the right category. It's almost like a game of matching. You're matching up protein with protein with protein. Okay? So then, as you keep reading, you see another at least 20 grams of fat. Okay? At least 20 means something is going to be greater than or equal 20. But they're talking about fat. So you've got to match it up with the other numbers that are talking about fat. So you go through and they're talking about food A right here, which costs blah, 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 and supplies 4 grams of fat. So food A, you're going to have 4x there. And then when they start talking about food B, you keep reading blah, 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 2 grams of fat. So that's plus 2y. Okay, you have to really focus and find the numbers that fit with the category that you're looking at. I'm looking at fat right now, 20 grams, 4 grams, 2 grams, fit it in there. Okay, so what else? You used a lot of the numbers. All right, food B is bought under a long-term contract requiring that at least 2 units of B So they say at least 2 units of B is used. So they're saying Y has to be greater than or equal to, right there. At least 2 units of B. Another contract requires that the amount of food B is no more than 3 times the amount of food A. So food B is not more than, what does it mean when they say not more than? Less than or equal to? So it says food B, that was Y, is less than or equal to 3 times the amount of food A, that's X. Y is less than or equal to 3X. Okay, and that's all of the numbers. Now, one thing that's a little tricky. Normally, we'll have this at the end. X is greater than or equal 0, and Y is greater than or equal 0. But one of those two equations or inequalities is not unnecessary. Which one? Why is the Y unnecessary? We already know Y is greater than or equal 2, so Y is greater than or equal 0 is not necessary. So let's get rid of that one. Don't need it. Okay? So there's the setup. Okay? There's the setup. Don't worry about the minimize equation, but plug in all of those constraints. We've got two x plus 6y, is greater than or equal 30. 4x plus 2y is greater than or equal 20. Y is greater than or equal 2. Y is less than or equal 3x. X is greater than or equal 0. Okay. Kind of hard to tell what's been shaded all those times. Maybe it'll help to make them the same color. Let's try orange this time. Okay, so it's really hard to see it. You might be thinking it's this triangle, but this triangle has not been shaded all of the times. And you can kind of tell because it's the darkest region. The darkest region is the only one that's been shaded all 5 times. Okay, so check it out. Notice how the boundary comes here, and then it turns, and then it comes here, and then it turns again and flattens out right there. That's the boundary that we're talking about. Okay, so right in here. So we still want the corners. Oh my gosh. We still want the corners. There's one, and there's one. But otherwise, this thing is unbounded, okay? Notice how it would keep going on and on and on forever off the page, off the screen or whatever. It's not a nice little bounded quadrilateral. It's this unbounded and infinite space, okay? So let's draw that in. I'm just going to do kind of a quick sketch. Got this and this and this and this. Okay. So only really need the first quadrant. And let's see what that looked like. I think that one's kind of hard to draw. But that's your feasible region. And your corners are 2, 6, and 3, 4, and 9, 2. 2, 6, 3, 4, and 9, 2. Okay. Now, Notice this one says minimize. That should make sense to you because if we tried to maximize an unbounded function, you'd never be able to maximize this because it's unbounded. Because you'd always be able to pick a larger and larger and larger x or y number, okay? It's infinite, but we don't have to be the maximum. We want the minimum. So let's minimize. We're going to plug in, same procedure though, 18x plus 12 times y. 18 times 2 plus 12 times 6 is 108. And 18x plus 12y, that's 18 times 3 plus 12 times 4, that's 102. And 18x plus 12y, 18 times 9 plus 12 times 2 is 186. Okay, be careful. Remember, you're trying to minimize. We are minimizing, and so the minimum number here is 102. 102. So the minimum cost is 102 cents. Okay, remember this was in cents. So that's $1.02. And the answer was, what was it, 3 and 4? So that means there were 3 units of food A and 4 units of food B.